Hey, 1, 1, 2.
Oh, that's pretty cool now.
Well, no, I reset it. Remember earlier on when you were over there.
Yeah, it's much nicer. Yeah, go on, keep going.
1, 1, 2. Checky, checky, 1, 2.
Mary had a little lamb.
Mary had a little lamb.
Our fleece is like yeah.
Fleecy sausages.
Go on.
Pay the people plenty of money. Ah, there we go. Still too low. Low ends kind of being a dick.
Keep going.
That's what I always say. He's a troublemaker. 1, 1, 2, 1, 2. Hey, hey.
That's plenty of level now.
Yeah.
Please, yeah.
Buckets, buckets. What about you? Can you see? Oh, you can see your level there.
That's coming in very nice, yeah.
It's
Yeah,
beautiful.
That's really, just talk there normally. Go on. Here on.
My name's Kieran. So,
That's your normal voice.
yeah, it's my real voice. Yeah, hunky dory. So,
Yeah, that's very nice.
so I'm just wondering why there's only two. Yeah, there's only two speakers working in here, and we said it to them. We went, yeah, we know. Okay.
So, oh, that's perfect.
Yeah, well, stop it now, yeah?
No, leave it go, but turn off can you mute the audio?
Yeah.
From me.
The lads are just doing a check. I can mute it here, yeah?
Yeah, we were
Okay, good evening all. And you're all very welcome to Maths Counts 2018. Normally at conferences we end by thanking people, but I thought I'd be different and I might start with all the thank yous before that. And just as a point of note, the Minister can't be with us tonight. This date didn't suit. Ciara O'Donnell, she's the director of the PDST, unfortunately couldn't come, so you're stuck with me saying a few words, okay? But my thank yous go out straight away to all of you who've come here tonight to support us, and also to thank all of the associates who have worked for us and supported us in lesson study throughout the year, and also to all the teachers who came out over all those long winter months to their lesson study groups. And to the principals and deputy principals of all of the schools who coordinated it for us and allowed live lessons to go on in the school and got substitution for us and for post-lesson discussions and so on. So I'd like to thank all of you who have helped us along on this journey, and also to the teacher education section for financing and supporting this conference. I think it would be opportune to have a look at the growth of lesson studies so far in Ireland. And back in 2014-2015, there were 8 of us on the team. We were RDOs, and we went out and there were 30 schools got involved with us and 72 teachers. And we did have a conference that year, and we put workshops on for all who came. And all of the lesson study groups worked out of education centres at that point. And then we moved on to 2015-2016, and we saw a growth in it. And we had to actually recruit facilitators to help us on the journey. So we had 14 facilitators, and we can see that the schools increased to 45 with 100 teachers. And then we put on our conference again with our workshops. But in that year, we started an online forum for everyone once they went out at night and participated in the lesson study with the help of the facilitators. All of the work was put up and shared and discussed on an online forum. And then you can see in 2016-2017, we now had 33 facilitators, so we had to recruit even more. And this time something began to change, because more and more we moved out of the education centres as schools said, we can facilitate, and so all of the lesson study groups worked out of schools, and teachers visited nearby schools, and so clusters were set up in that way. And last year was the first time that we put live lessons on here at the conference. And both Akihiko last year and Tad has said that outside of Japan, they have never seen a live lesson taught at a conference by teachers from their own country. So whilst Akihiko and Tad travel the world promoting lesson study and working with ministries of education, they said that outside of Japan, they have never seen, though, teachers from their own country teaching live lessons. So we're a first for that here in Ireland. But last year we saw a growth again in the number of schools. 106 schools participated with 150 teachers. And our workshops changed last year as well as a response to what you had told us, and they became more interactive in fashion. And that leads us then to this year. And we had to recruit even more associates. So we now have a team of 44. And we were working out of 150 schools this time across the country, and 400 teachers participated. And this year we had 72 research groups set up across the country. So it may be small, but it is incremental, and sometimes that's the way you're best to approach things. If we could look at the map of Ireland, it's nice to see that last year there's where we were operating from, all of those schools. And this year, you can see that it's even more populated. And Dublin there was an awful lot of little ticks went in there. So it has grown. And so lesson study is really, and has been for years in Japan, seen as a mechanism for change. And in Japan, they've been practicing it for over 100 years. So from the 1880s, and every single thing that the Ministry of Education wished to introduce in their education system, in mathematics, and indeed every other subject, lesson study was used as the model for CPD. And you can see that that brings us up to the 1980s, and that was where problem solving came into the sort of the focus, if you like, in Japan and indeed throughout the world. So Japan only sort of began to focus in their curriculum in the 1980s, but they had put a lot of work into it in the 1970s. So if we were to look then at this more closely to see, well, what has lesson study managed to do in Japan for problem solving? But first of all, if we could just keep in the back of our minds that lesson study is a model of CPD, right? Some people mix it up with problem solving, but actually lesson study, it's the model for CPD for teachers. So let's take a look at then the success of Japan. As I said, it was in the 80s that was introduced problem solving, a focus in their schools. And before we do that, there was something else I have to say, sorry. Just to maybe give you a background to the conference, that in our lesson study cycle, and a lot of you would be familiar with this, but all of the teachers who participated countrywide, they met for 5 or 6 evenings in their own time after school hours. Now that's the unglamorous side to lesson study, going out in the evening time and participating in this. But on the first evening, what all of the teachers did was they identified what the research theme was for their school for the year, in other words, their SSE, and looked at how they could, in a meaningful way, in their maths classroom, integrate the standards that their school was working on a day-to-day basis. And they also identified an issue, either in their teaching that they found challenging or something that students found difficult to understand. And then, this is all the work you don't see, okay? The teachers coming out, and what they did was they set about planning. And all of this work was to develop a lesson proposal. And they looked not only, as I said, at their SSE, they looked at the junior cycle key skills and statements of learning, but an awful lot more than that. And you will see the lesson proposals and so on, and you have them on your pen drive, all of the work that has gone into developing the lesson proposal. And after that, the teachers then in the schools, one of the research group taught the live lesson in front of their peers, and after that had a post-lesson discussion. So very much the live lessons tomorrow, you'll see the live lesson and the post-lesson discussion. And at the interactive workshops, you'll hear the story. But you certainly won't have seen, this is all of the planning and so on is not visible to you, all of the work that the teachers put into that. And as I said, if you think of it, 400 teachers came out for 6, 7 evenings for 2.5 hours each evening. That's a colossal amount of hours invested in this. So that's the background to the conference. And here we're sharing the outcomes with you. So as I said, we have lesson study as a model of CPD, and we said that the Japanese teachers, when they were introducing problem solving, for many, like they had in many decades before, they used lesson study as a model of CPD to introduce it. And that's what we've been trying to do here in Ireland, and indeed all of the lesson proposals all focus on teaching mathematics through problem solving, or as it is translated as structured problem solving. So we're talking about two different things there, the model of CPD and the problem solving. That's what is the model of classroom practice that we're looking at. So if the Japanese then introduced problem solving in the 80s, it's always interesting to look at how well they're doing on international tests. And we're going to look here at TIMSS. And this is the results from 2015. And I know a lot of you would have seen it, but it's always good to be reminded of it. So we have the benchmarks there from low up to advanced. And if we're talking about low intermediate, we're talking very much about skills and being able to reproduce procedures and so on. High and advanced, we're moving more into the realms of problem solving. So internationally, the blue here represents international, and that there would mean 84% of the students reached the low benchmark, and 62, 26, and 5. So that's internationally. So let's compare Ireland with that. So 94% of our students reached the low benchmark, 76, 38, and 7%. So looking at that, you'd be saying, well, we're better than the international average. So let's see then about Japan. Right, we're better than them, yeah? Now, therein lies a story, yeah? That when it comes to the high and the advanced benchmark, in other words, the problem solving, you can see there how much better they are than we are at it, okay? Let's take a look at science and see how do we compare with science. So again, we have the international. And again, there are the percentages. If we look at Ireland, so again, we are above the international average. And let's see Japan, because the Japanese also use lesson study and problem solving in those lessons as well. So if we look at the Japanese, sorry, they're ahead of us there, there, and there. So I think 34% and we're at 10%. As I said, therein lies a story. So whilst we can't import necessarily systems from other countries, we can though actually learn from them. And anyone who has participated in lesson study with us will say it has made a difference. And if you were listening outside to the video clips, the teachers who've got involved will also say, it's not just, though, about that unit of work. I'm beginning to think about all of my teaching differently. But remember, lesson study, it's not a one-off event. You don't participate in it once and tick the box and say, I've been there and I've done it. It is something you practice year in, year out, year in, year out. That is what the model uses. So if we look at, and you would have all got one of these, and if you didn't, you should pick one up. It's just our handbook to explain lesson study to you. We were looking then this year as well that in the system at the moment, there seem to be quite a number of strategies going on. So on teachers' desks have landed our action plan, the junior cycle with its framework and its statements of learning, and of course the key skills at both junior and senior cycle. We have then our literacy and numeracy strategy, which we're still meant to concentrate on, our school self-evaluation, looking at our schools, which gives us indicators of practice. The digital strategy has landed on our schools. STEM education is a priority, and a framework has come out for that. And of course then the government and so on looking all the time at PISA and TIMSS. There's a lot going on, isn't there, when we look at all of that. And we found that the teachers were saying to us, it's as if we're spinning plates. We're keeping this one going over here, but then there's this one going over here, and we feel like we're spinning plates in the school. And we used lesson study to actually integrate all of these into lesson study in a purposeful way for everybody. Because at the heart of all of those strategies, there are three things: teaching, learning, and assessment. and making the system better for our students. But what Lesson Study has done, and indeed if you go to the interactive workshops and if you look at the lesson proposals, you will see that the teachers are all saying Lesson Study has put together all of these strategies in a meaningful way. They're taking them and putting them into their classroom, as I said, in a way that makes sense for them. So, moving ahead now, just to remind you, in case you didn't know, this conference was meant to be held on the 3rd and 4th of March. And then there was a little thing called Emma, disrupted it. And as a result, there's a little bit of a shift, and I hope you will understand that it is normal for us to have wine and canapes. Tonight you're having tea and coffee, okay? So it's just things had to change. It couldn't stay the same, unfortunately. And the other change I want to draw your attention to tomorrow is that the interactive workshops are behind us in the Health Science Centre, okay? And it will be signalled for you. But I want you to know, and I'll be reiterating it again tomorrow, that really and truly, the rooms out there, they will hold you, but you may not get the choice you want. So if I were you, tomorrow your lunch, I would get up and over there and get into my room, okay? Because it is going to be tight. We do expect 450 here tomorrow, okay? So it will be tight in the rooms. So that's what it looks like. Tad is going to come in with his live lesson. And again, this is another change. On the conference programme, we told you it was going to be a 5th year ordinary level class. It is communion time of the year and confirmations, and a lot of the students weren't able to come. Tad had actually, just before it snowed, made it to the school in RD. He had taught the 5th year ordinary level students. Lesson 1 was in the bag, and he was going to then continue with lesson 2 and 3. Obviously, we had the snow. Tad flew back to America. Tad flew back from America. He's now with us. But unfortunately, he couldn't make it this morning. So we've had to get a new group in the school, and they are a 5th year higher level group, okay? And this morning, I went out and I taught them in the school. So if it all goes wrong on Tad, you know who to blame, okay? Me. So just to clear it up, how some things have changed. So just a few more little things. Don't forget to enter your prize, and we'd like to thank Microsoft for the Surface Pro, and we will raffle that tomorrow before Shane Flanagan, team leader of JCT, will provide us with insights back in here about the new junior cycle mathematics. I believe, I've been told, we're having a tweet of the day tomorrow. And also to bring to your attention that whilst you may not be getting wine and canapes, we've given you this. Now, you've got the first edition, okay? But it's also to bring to your attention, this is the last time you will see that symbol, our logo, Maths Development Team. For ease of the transition, we moved into the PDST this year, and we just kept the logo so that everybody could still identify with us. But from next September, of course, there is still math support for you, but it will be within the PDST, so you'll be just looking for math support PDST. So we've come full cycle, and that's going to be the last one of the logo, okay? And I think it's opportune just to remind us, let's look back nostalgically at the Maths Development Team. We've done a hell of a lot of work since 2008, and there's so many people who have helped me along that journey. But there are a host of resources there, and you know, it certainly was. As I said, I look back on that, and there was blood, sweat, tears, but there was a lot of fun along the way. So I think now it's time to welcome our guest very soon. But he is internationally known. He was with us here 5 years ago. I'm delighted that he's been here twice this year already. And he's coming with students from RD Community School. And we'll show you what happened this morning with them. He's also going to provide us with a keynote address tonight, Lesson Study in Ireland, where do we go from here? And just to put the frame what's going to happen next. This is the goals of the lesson this morning, or sorry, for the unit of work that Tad has planned. And he's calling fractions and their curious behaviour. And these are the 3 goals for him for tonight and tomorrow. That students will understand that algebraic expressions are useful explanation tools, that students will extend their ability to add and subtract algebraic fractions, and students will continue to develop mathematical proficiency. This is what happened this morning in RD Community School. We explored the addition of fractions. The students themselves came up with this formula for adding and subtracting fractions. We came up with an observation that we had a third fraction which is obtained by adding the numerators and denominators. And we used this new fraction of a plus c over b plus d, and we set up that expression there, and we were trying to explain why that observation is true. As I said, I was lucky to have seen Tad teach it back in March, so I tried to copy what he did in RD. It was very telling. Everywhere you see S, the student answered, and T was me, teacher. The students, yes, they added them, no problem. They talked about common multiple to me. They understood that you don't always need the LCM. I asked them could they express in an algebraic way a formula for addition and subtraction, and there the students came up with it themselves. They told me what the common mistakes were. I asked them how would they know which is the smaller or the biggest fraction, or why was it incorrect. They could tell me. We looked at it on a number line and saw that a plus c over b plus d was between a over b and c over d. The students set it up as an inequality. They talked about a, b being maybe the smaller fraction, c over d the bigger one. And they also gave me the conditions. A, B, C, D should be positive whole numbers, not equal to 0. And then a student said, sure, they're the natural numbers, aren't they? And then I asked them, how did they know that that is true? And we looked at the first inequality first, and one of the class worked it out with numbers. And then someone else realised, well, gosh, if you subtract them, you might know whether something's less than naught or greater than naught. And that's what they came up with there. And so I explained that because not everybody was clear about it. And they then got the idea that they could be subtracted. If it was greater than naught, A over B was biggest. If it was less than naught, A over B would be smaller. And that's where we finished. So with no more to do, and that's tomorrow's, I'd like to welcome, and these are the real stars of the show here tonight. And I've met them this morning. They're the loveliest group of kids I've ever met. Okay, and they are from RD, where I'm from. They are from County Louth. So could we welcome, please? Here we have 50 of students. A round of applause for our esteemed guest, Professor Tad Watanabe.
I'm mic'd with this, right? This is for. 1, 2, 3, 4. That's fine. That's fine. Are we ready? Yeah. I guess the question is whether I'm ready. All right. Let's see. I'm trying to figure out. So I'm gonna hand this to you, and then I ask you some questions so that the people in the back can hear, or the cabbages in the back can hear you. Okay. So. Okay, so what I want to start out with is to revise what Dr. Brosnan did with you this morning so that I can be on the same page as you are, right? So in general, what was the topic you were talking about this morning? Fractions, right? And what about fractions did you look at first? Addition and subtraction. The way we add two fractions, kind of weird ways that, I mean, when you add fractions properly, we do it some weird things, right? It doesn't necessarily make sense, but, and I think I understand that I need a big table for myself. You looked at, I lost my cap. Oh. I don't want to mark on myself. Okay. Thank you. I understand you looked at some kind of a formal way of writing additions, like A over B plus C over D, right? And what do you have to do when you add fractions?
Multiply the A by the B.
So
Plus, or the same A multiplied by D, and then it's plus B on the numerator, and plus B multiplied by C, and that is equal to, or over B multiplied by D.
right, so because this is the common denominator, right? And we need a common denominator before we can add fractions, because numerator tells us how many of something we have, and denominator tells us what we have. So you can't add, people talk, I don't know, do you say in Ireland you cannot add apples and oranges? No. Right, that phrasing, right? If you're counting apples and counting oranges together, you can't just put those numbers together at the end, you don't know what you have, right? So you have to have something common, right? And then subtraction is basically the same thing, right? And end up with minus BC instead of plus BC. Okay, so that's something you did. Then what else did you do?
Linear inequalities.
Yeah, you looked at inequalities, but what inequalities between, among what? Yeah, like this. It's a mistake, but you would think that you can do that, right? When you first learn fractions, if you want to put together two fractions, as natural thing is at the tops and at the bottom. What's wrong with that? It turns out we can't do that, but the mathematicians are, what shall I say? Is there any mathematicians in here? I don't know. I don't want to offend anybody, but they're kind of weird, right? So they start paying attention to things. So, you know, if you add together, so if you're given, there are two sides to this markers. I didn't know. If you're given two fractions, oops. And let's just say that's the way it is. They get curious about, well, what happens when we can't do this to add two fractions? But is there anything interesting about that thing? Right? And what did you find out about this? In between these two original fractions, right? So it turns out it looks like that. But we weren't quite sure if that was really the case. Oh, and another things about weird characteristic of mathematicians, they have to be really careful about these letters, right? So these A, B, C, and D, we just, for now, we just says it's going to be a positive numbers. It's really what we don't want is the denominator to be 0. But we want to know whether this is true or not. And what else did you talk about? Did you talk about possible ways of doing that? The showing? Okay.
By subtraction.
Okay. Donald is the first one to get to speak with a microphone. All right. So we talked about, I think you may have talked about, whenever mathematicians are comparing two expressions, right? If you want to show like this expression A is like expression B, one of the strategies they use is, well, that's true if A minus B is negative, right? Or I guess you can do B minus A is positive. Either way would work. So this is possible strategies. So there are actually two inequalities we wanted to look at, right? And so you started looking at, which one did you look at in class this morning? The first part? So you wanted to show whether or not this is true or not. So you wanted to see and did you do anything with that? You did subtraction? Actually, can somebody do this, what you did in class? Yeah. All right, so how you decided where to sit, I have no idea. But in this auditorium seating, these three are in the positions that's easiest to come out. Can one of you just show what you did? Okay, there. That's what you wanted to show, right? Good. So did you actually try to figure this out? Yeah. You did? All right. The other 5. Remember, there are cabbages out there. Do you know how to do this subtraction? You did, right? You don't have to say anything. Just all right. What do you think? Thank you. What do you think? Yeah? What? Do you want to come out? So then you have a choice of either speaking or coming up.
The B and the D should be in brackets so that they're...
This B and B
Yeah.
plus D?
Yeah,
This should be in brackets?
so that they're both being multiplied by the A.
Okay. Does that fix it? Well, this is what we want to show, so, okay. Kevin, what are you looking down?
Well, I think I have wrong this.
You have something different than this?
That's not different. I just go A bracket B plus D minus B bracket A plus C over B bracket B plus D instead.
Okay.
So as in the bottom bit's right, but I'm not sure about the top bit.
So maybe you're trying to do way too much at once, right? So what are you trying to do when you try to subtract? You have to find common denominator, right? What will be the common denominator in this case? So B times the quantity B plus D, right? So if you want that to be the common denominator for this first one, what should happen to the numerator on that first fraction? So A was here, right? All right, Tara?
Do you not just multiply it by B plus D?
You have to multiply it by the same thing, right?
Yeah.
Then, well, this is the same, right? Because we want that to be the same. So I guess since I can't have you guys come out as easily, maybe I'll just hand out the microphone. So what happens to the second fraction?
Is it A plus C on B
So it's just A plus C was already there.
and then multiply it by B?
Is that okay, everybody? Is that okay? Jasmine? Yeah. I'm only picking those of you who I can remember the names and faces together. So now you're hoping that I don't remember your names. So can you finish this? What would the numerator look like?
B squared plus BD.
B squared plus BD?
Sorry, the numerator.
Oh, the
Sorry.
numerator.
Sorry. It would be AD minus BC.
AD minus BC?
The AB's cancelled.
Are you sure?
It's AB plus AD.
AB plus AD? What do you think?
AB plus AD.
AB plus AD? Michelle?
AB plus AD.
Okay. So, I mean, everybody has paper, right? Just try see what happens. So what did you end up with on the numerator?
The numerator.
On the top, yeah.
AD minus BC.
AD minus BC.
Yep. All over B squared plus BD.
Oh, you want to multiply
Oh.
them out. Sorry.
Oh.
I'll write it down. Do you all agree with that? Yeah? So we're done, right? Yeah? Why are we doing this? What?
Prove that it's greater or less than A plus B. Or
Can
no,
you
greater
tell?
Than, no.
Can you tell it's less than or greater than 0? No? AD minus BC over B squared plus BD. Is it positive or negative? Either way. Can't tell? Okay. So when you're trying to show this, A is less than B, we can subtract A minus B is less than 0, or we can try to show if B minus A is greater than 0. So what if we did the other way? Maybe we can show it that way. Right? So if you try to do this, A plus C over B plus D minus A over B. Can you do that calculation? What's the common denominator? Can you do that on the board? Sure. Just sort of, you can say scope here. thank you. What do you think? What was your name? Brian. Oh, okay. Brian. Okay. So what do you think about what Brian did? Brian. No, Brian. Where'd you go? Yeah, okay. Brian. Okay. So what do you think about what Brian did? What do you think, Brian? Now that I got your name. Is that right? Yeah? You sure? So if I keep asking, you get less and less confident? Is that the deal? So here you go. Why do you put brackets around b but not b plus t? That's okay. I know what you meant. Right? So what's the common denominator Ryan's using? If you calculate it, it ends up as b squared plus bd, right? So to get that, you have to multiply this numerator by b, right?
Yeah.
Because you're multiplying this by b as well. So that's b times the quantity a plus c. Is that how you say it? Okay. And this one, you're multiplying both denominator and numerator by the quantity b plus d. So you multiply a by b plus d. Right? Then you do this. So it's, I probably should equal sign. Well. So now what? Do we know if that's greater than 0 or less than 0? No? We still can't tell? Why not? Don't we know it? What do we know about A, B, C, and D? They're all positive. Right? What else do we know? Do we know anything else? They're not 0. I mean, where did A, B, C, D come from? You hate when your math teacher's asking these kind of weird questions, right? But
C over D is greater than A over B.
say that one again.
Do we know C over D is greater than A over B? Like on the left one.
Oh, this.
Yeah.
Oh, we know this, right? We're given this.
Yeah.
What do you mean? Oh, okay. Right? So if we know this, can we say anything more than A, B, C, D is positive? Remember whenever you're showing this, it's like this, right? If A is less than B, well, the expression A is less than expression B, that means if you subtract expression B from A, that's going to be negative. So what can we say about from here? So this is true if you say C over D minus A over B, that should be positive, right? Because we're saying this is bigger than this. So if you subtract something smaller from bigger, it should be positive. Yeah. Or we can do the other way around, right? A minus B. We can say A over B minus. That's given. Right? We don't have to put the question mark on like. This is what we're trying to show, so we can't say it yet. But this says we're given this, so we can say this. So what does that mean?
AD is less than CD.
AD is less than CB? How do you know?
If you bring it across and then cross multiply, you get like AD is less than.
Oh, okay, so you're doing cross multiplying. So you don't necessarily have to do this.
I'm imagining AD and CD you have on that equation. AD, BC minus AD.
Yeah, there's AD and BC are in these guys.
Yeah, and then you can yeah.
So now he's stumbling along, so I'll hand him the microphone.
And then you can see as soon as the mic came, I don't know what I'm saying. And then you can see if it's less than or greater than 0 on the top.
Okay, so somewhere along the line, when you're learning these comparing fractions, some of you may have learned this cross-multiplying thing. I think that's what Ryan was. So this is another thing is that he's saying that if that's the case, that's the case. Right? Just this, he multiplied. Is that okay? Right? Well, I guess we can go with that. So what if we can say this? Then what can we say that? This is less than that. BC minus AD is positive or negative? It's positive. So do we have BC minus AD somewhere? Yeah, in the second one. Oh. So do we know the answer? Is this positive or negative? What about this part? That says this part is positive, right? Oh, so yeah, this is another thing we said, right? So b squared must be positive because any number squared is positive. BD must be positive, right? Positive times positive is, and then if you add positive and positive, you should get, so this is positive, this is positive. Fraction means, another way of thinking about fraction is thinking of like a division, right? Numerator divided by denominator. So it's positive divided by positive. So it should be positive. So what about this one? This part is negative, and this one is positive. So negative divided by positive should be negative. So this true? Yeah. So this is no longer the question mark. This is true. Are you convinced? Not so much. Yeah, because we're just like applying with these letters. Yeah. You sort of understand, sort of follows logic, but seems like somebody was trying to trick you somewhere along the line. Right. But what we are trying to do is, if this is true, and if this is true, that means either this is negative or this is positive. Right. So we just try to do the calculation, and at the end this turns out that it looks like it is positive. So this is indeed greater than 0, and this is indeed less than 0. So that seems like this is showing that this is true. Convinced, Kevin? Yeah? Ashlyn, what do you think? Yeah, sort of. Asking Ella? Are you convinced? How else can I ask so that? What if I said that's? I'm not convinced with that. I should be.
No, just asking why.
Yeah, you know, hey, this guy came from somewhere. Maybe he doesn't really know what he's talking about, right? So why should you believe it? Right? I mean, do you see anything wrong here? He did this calculation correct, right? And this argument here, is that okay? Is that the part that just sort of... But this came from all this, right? We said this is the case. And if this is the case, it has to be this. And that means it has to be this, right? So where's is there any holes in the logic reasoning? You can't see any hole, can you, Jenna? No. No? When a teacher asks that kind of question, you know what the answer is supposed to be, right? That's something I need to learn better. But. All right, if that's the case, are we done? We show one inequality. We have to do the other side, right? So let's see, where is the other? Ah, they're here. So this is no longer question mark. So can you show in your in your notebook the A plus C over B plus D Can you do that? So you want to subtract, right? One from the other. Either way is okay. And when you're doing subtraction, you have to find the common denominator. Just do this on the board. That's me. can take the paper if you want. So can you tell which is positive or negative? Okay, so asked Jasmine to write what she did. So she was, I guess she was doing this subtraction, right? So this is still question mark. We don't know until at the end, right? So this is equal to this. Is that, what do you think? Going from here to here, did she get it? Do you get something different? So you multiply both C and D by this quantity B plus D. So that. This one you have to multiply both by D. That. Is that okay? Looks okay? Yeah. And does this simplify this? BC minus AD? How many of you did this subtraction? How many did this way? I think I saw some of you this way. Right. You did this way. Right. How many did this way of subtraction? Okay. So for those of you who did this way of subtraction, is this what you came up with? Yes? Okay. And then Jasmine said that's positive. Is it positive? You think?
Oh, well, I said it was because see over there, you said, because see over there we said BC minus AD is greater than 0, so I said it's positive.
Okay, so that's positive.
Yeah.
And this is also positive.
Yeah.
So it's positive over positive must be positive.
Yeah.
Okay. So who did the other way of subtracting? Okay, so what was the, where does this end up? At the very, after you simplify?
CB minus DA over BD plus D squared.
And is this positive or negative?
Oh.
Do we have, I guess this is same as BC minus AD, right?
Oh, sorry, that's wrong.
We did it wrong?
Yeah.
What should it be? Grace?
DA minus CB over.
Oh, okay, this is reversed?
Yeah.
DA minus BC?
Yeah, so it's less than 0
And how do you know that?
because of the
What does it say?
AD is less than BC.
AD minus BC is less than 0.
Yeah.
AD is less than BC. And this is
Positive.
positive, so this is. Okay. So we can now say this is also no longer a question. Right? You convinced? Sort of. And but that's one of the things about algebra, that these letters, variables, gives you a way to show something, right? This may be something you need to sleep over to try to really convince yourself whether or not it's true, right? So you're almost running out of time, but so what does this? Oh, I can cross out that question mark. What this means? There are a couple ways you can think of. Right? One way you can think of is that this means there's no such thing as next fraction. Right? So like if I say, if you're looking at the whole numbers, you know what whole numbers are, right? So, Sarah? No. Duran. Okay. Lauren. Right? Sarah. Oh, Sarah. Okay. So, Duran, if I ask you, what's next whole number after 13? 14. Are you sure? Yes. How do you know? 13, and then why is it 14 next? Well, there's nothing in between, right? If you say 13 and 15, says, no, there's 14 is there, so the 15 cannot be next to 13, right? So if I ask you, Laura, if I ask you, what's the next fraction after 1/2? 1/3? What do you think? Is 1/3 next to 1/2? No? What's next to 1/2? Nothing else?
No, it's just very minutely different.
Minutely different? So if you say 1/2, actually 1/3 is actually getting smaller, so you can say that's not next. Well, then we can go the other way around. Is 1/2 next to 1/3? Well, what that says is there's something in between here, right? Yeah. What's the in between we know? 2/5 is in between them, right? So that can be next. So maybe 2/5 is next to 1/3. Is it? Why not? What? There's something in between here? 3/7? Or maybe 3/7 is next, right? No? Why not? There's something else in between them, right? How long do you think we can keep doing it? We can keep doing it forever, right? So that's what it means. Like, we know what's next to 17 in the whole numbers. But with fractions, that tells you there's no such thing as next fraction to any given fractions. Because whatever you name them, you can find something in between them. And you can keep doing this infinitely many times. That means between any two fractions, there are infinitely many fractions in between them. That's weird, huh? This infinity deal is really weird. So you pick something like 9/10 and 11/12. Those are very small numbers. But there are actually infinitely many numbers in between them. Right? That's kind of weird. And actually, mathematicians would say the fractions, the rational numbers are dense in real numbers because there are infinitely many in between any given two rational numbers. And it turns out there are actually more irrational numbers in between two rational numbers. That's something else you can study in college. But that's one of the powers of mathematics, that we are a finite being, but we can actually start thinking about infinity that way. So, Dr. Brasnan, was that reflection paper?
Oh, the reflection. The one brought down. We can get it.
So hold on a second, right? What did you think? That's weird. What do you think? Stephen, you gonna say something? No, fine. So once I get the paper, I want you to write like a reflection you did this morning. Just write down what you thought. What do you think, Jenna?
Yeah.
Did you have anything you want to say?
No, I'm not allowed to say.
No? Well, come tomorrow, I would not remember your names and faces together, but there. No. Delton. That's there. What do you think?
It's pretty obvious, but like you wouldn't really think of it straight away.
Okay. Yes. They just all started with this sort of the common mistake thing, right? And mathematicians think about these things and start thinking, is there any other patterns that we can tell? It looks like it's a mistake from one perspective, but there may be something more interesting in there as well. Right? Mistakes are not always bad. In fact, a lot of times we can actually figure out something interesting out of mistake. Right? I'm sure your teachers told you many times that you can learn from mistakes. But I don't know how many of them actually taught you how to learn from the mistakes. Right? But this is kind of things. Okay? It looks like this is not how you can add fractions. But when you start seeing them, you notice some patterns and you start thinking, is that always going to be in between? And if you can show that it's always in between, then that you can start seeing some properties about fractions that is not true with whole numbers. So, oops. Oh, see, I don't know how to count. There's this joke about math teachers. There are three kinds of math teachers. Right? There's a bunch of math teachers back there. Well, they're cabbages. Okay, sorry. But there's three kinds of math teachers: those who can count and those who can't count. If you're not laughing, you can think about that. We have a couple minutes to write, so. So just finished writing. But thank you for coming tonight. And I'm looking forward to working with you tomorrow again. And I hope you get good rest tonight. And what time would you have to leave tomorrow? 6:15. That's dedication. It's for all of us, these kids are doing that. So thank you very much for doing that. So when you get done, you can just give that paper to me, and I'll see you tomorrow. So I don't know where somebody's taking them back. Okay. And just says, okay, you guys are on your own. You just go home. Yeah. So. Yeah, thank you.
Okay, I believe they're all going home
Thank you
now
very
to go to early bed tonight, I was told, yes? I think they have something planned. Anyway, we'll see you in the morning, bright and early, yes? And thank you very much, okay?
Thank you. Thank you. Thank you. Thank you. See you tomorrow. See you tomorrow. See you tomorrow. All right. Thank you. See you tomorrow. Thank you. Thank you. See you. See you in the morning. Thank you. Thank you. Oh. All right. Thank you. Thank you. See you tomorrow. Okay. Thank you.
Right. Tad is now going to deliver a keynote address to you all. Okay, so we'll pass over to Tad. I hope you're as interested in that lesson as I was. It was absolutely superb. So over to you again, Tad.
Okay, thank you.
Do you know how to?
Yeah.
We're working off this one here. Yeah. So it's this. That's me there. And yours is here. Okay?
Okay, thank you.
You're okay, you can take them there.
Okay, so good evening, everyone. Dr. Brosnan said I have a few more minutes than I was originally given. So just my sort of reflection on the lesson. When I was planning the lesson, one of the goals I had was I wanted the students to start seeing the sort of usefulness of these algebraic expressions to be able to show something is true or not. It's quite obvious at the end. It's still, okay, everything seems to follow the logic, but it's not quite convincing to many of them. And there are still a few that where doing the algebraic fraction is problematic for them as well. So, but I wanted these lessons to be more based on problems where they actually use addition, subtraction, well in this case really just subtraction of algebraic fractions instead of this is how you're supposed to subtract, because in part because they have been taught that or they have been told that before. And there are probably many different reasons that the students who have difficulty with these algebraic fractions, And if you try to go back to the way we think about fractions, that might be the way to deal with that, really the fundamental issues. But I wasn't quite sure if I can go there in these 3 lessons. And I wanted to see what the students can do as well. Of course, the Beast from the East didn't help because I wasn't able to work with the students in the first part of the lesson. But I think Dr. Brosnan did a great job in getting the students to where they were so that I can get started tonight at where we started. Any comments, questions from you? I'm perfectly willing to subject myself to criticisms. Yes?
I was interested in what you were going to say to the student who said that to cross multiply. If you had more time, would you have said something differently to them?
This here? Yeah, I think I would have actually gone through, okay, why this is really the case is by looking at, well, way to compare fraction is by having the common denominator. Or we can keep doing this as well. You end up with AD is less than BC from that as well. But doing that, having the common denominator, and then says comparing fraction with the same denominator is easy, right? Because you can just simply look at the numerator. And it turns out AD and BC are the numerators of the equivalent fractions that we create once we create the common denominator. So I would like to have actually gone through that part. But for that moment, I was debating with myself whether or not to go back to this. But I got the impression with many of them, this was okay going from here to here. So I thought I'll just leave it there for this time. But I've seen many students who use that cross multiplying get confused which way it's supposed to go at the end. So.
Sorry, yeah, following on from that, if they had done that approach, say at the top of the board there,
then
at that stage, would you have just let that go with the lesson then? That way because it makes it an awful lot simpler.
Yeah, I think that's okay too. Yeah.
So
then you don't have to do the actual subtraction of algebraic fractions.
Yeah, if they'd have come up with that, you'd have just let them
Yeah.
go that way.
So that in itself sort of shows their sort of fragility of their knowledge about cross multiplying, what that means. Of course, at this stage, using cross multiplication is problematic in the sense that we don't know if that inequality is true. Here it was okay because this inequality was already given. But then when you start getting into that kind of subtlety, that's a really mathematical subtlety that I know many of my students have difficulty with. When you're trying to show something, why you can't say that in the proof of showing it. And I think there are plenty of adults who are having difficulty with that circular argument issues. So, but fortunately for me tonight, nobody did. So. Well, then I guess it's already 18, so I should probably get going with my talk. I always wonder about, in the classrooms or lecture hall settings, why the clock is in the front wall. It's the ones who don't need to be paying attention to the time are the ones that are seeing the clock. And the one who should be paying attention, you have to turn around to see it. But anyway, this is kind of like the joke you hear about the preachers putting his wristwatch on his, what do you call it? Not lectern, the pulpit. And a boy asked his dad, "What does that mean?" The dad said, "It doesn't mean a thing," right? Because the preacher is not paying attention to the clock anyway when he preaches. So anyway, so it is really a great pleasure and privilege to be back in Ireland again. I think being invited back to something means something special, at least professionally, because it probably meant the first time you came, whatever you did, you said was useful or meaningful. They thought good enough about to invite you back. So I was really pleased Dr. Brosnan invited me back. So I wanted to talk a little bit about this lesson study in Ireland. Where do we go from here? So I want to start out with what's happening in Ireland. This is the outside looking in perspective of lesson study in Ireland. Right? But some of which I learned from, I went back to actually looked at the Dr. Brosnan's presentation from the Mass Counts 2013. But prior to Mass Counts 2013, Dr. Brosnan told us that they tried to implement lesson study for the first time during the school year 2008-2009. But that was apparently immediately following the release of the new syllabi or syllabuses. Okay. And they decided that math teachers are already dealing with this new syllabuses, and trying to do lesson study and other new things on top of that is too much. So they decided to stop, and for a few years they had the dormant years. But in 2012, they restarted lesson study. And then November 2013, first Math Counts meetings, where I was privileged enough to be invited to give a talk. And then there were 25 research teams share their learning from their lesson study. 2015, Professor Jeffrey Wake from UK gave Keynote Address, and 21 research teams shared their learning. They didn't necessarily skip 2014, because this was 2013 was November, and this was February or March. So it wasn't really year was skipped, but that was 2015, second Math Counts meeting. In 2016, Professor Akihiko Takahashi from DePaul University, my colleague, and we worked together a lot, he gave a keynote address, but also he did the demonstration lessons during the conference. And then you had, this time, 48 research teams shared their learning from their lesson study. And last year, 2017, again, Professor Akihiko Takahashi came and he gave the demonstration lessons and also the keynote address. But in addition to that, there were 3 research lessons by Irish teachers during the conference. That's a huge step forward, I think. And then 52 research teams shared their learning. And I think this was in the program showing the growth from 2015-16 school year to 2016-17 school years in terms of number of facilitators, number of schools, and number of teachers. And then this year's about 70 poster presentations that you get to see after this. 24 interactive presentations tomorrow. And then again, 3 live research lessons during the conference. And this came from the program for this year's. I'm one of those math teachers who can't count. I try to count and I can't keep it straight. There are more than 150, I think. So looking at this, when I first saw this from the program, my reaction was, well, this is pretty American reaction, I guess. Wow. In 4 years, 5 years, you've come quite a bit. I mean, this idea of this live research lesson second time around, I think that's very significant. In Japan, we often talk about doing something first time is very important too. Right? But then doing it again, doing the second time, and then doing it a third time, that takes a lot of commitment and dedication, and then keep doing it, making it into pattern. And so I think lesson study in Ireland has progressed quite a bit since restarting in 2012-13 school year to this year. So in the next 20 minutes or so, I want to share what you might want to be thinking about where we go from here. Now, I'm doing this with somewhat of, well, not somewhat, obviously very limited knowledge of Irish school systems and school culture. So some of which may be completely off target, but it's really up to you to figure out which part may be something that you can be thinking about and as you move forward with lesson study. Right. This is a sort of pictorial way of depicting the Japanese lesson study cycle as typically practiced in Japan. This came from the publication by Dr. Takahashi and his colleague, Dr. Makoto Yoshida, and appeared in the Teaching Children Mathematics in the US. But this group here inside of pink is the lesson planning group. They develop the lesson plan, and they conduct these research lessons, kenkyū-jugyo in Japanese, and then that's observed by these other folks, and then they have, all of them have post-lesson discussion from which this new idea for teaching and learning happens. The group will summarize their learning, and they restart their lesson study cycles. Okay. So this is really a simple way of depicting the lesson study as commonly practiced in Japan. But what I the first things I want you to think about is how many green and blue dots are there in Irish practice of lesson study. Right? So the green dots, these guys. Green dots are other members of lesson study group. Okay. So there's a lesson study group in Japan. Oftentimes you have a bigger group, which is part of the lesson study group. Subset of that plans a research lesson. So the other member, the other green dots, are not necessarily involved in the planning stage, but they come to observe the research lesson and participate in post-lesson discussion, and then maybe even reflection of their learning after the post-lesson discussion. One of the benefits of doing that arrangement is that it really developed these sort of solidify the common vision of mathematics teaching among the group members. And that's also part of the goals. They want to develop and solidify their view of teaching mathematics. So they work together. So those green dots, they may be in the different planning groups. So in the different research lessons, some of the green dots may be in the planning part, and then planning part, that those people who are in the planning team with the initial set, maybe the green dots in the second research lesson kind of things. So they end up having cycle of the several cycles of research lessons. Blue dots are the educators from outside of those group coming to observe research lessons. And what they do is they provide fresh perspectives. I don't know about you, but when I'm involved in planning something, I start developing very narrow, almost like a tunnel visions. And then we think that's the correct approach to do things, but then having these fresh perspectives, that shakes you up a little bit, is very important. And these blue dots provide that. Right? But they also play the role of spreading these ideas beyond the team. They came to observe something, they learned something new, they agreed with what you were presenting, and they try to implement that ideas in their own settings. So that in that way, you can spread the ideas outside of this lesson study group. Right? What I'm not quite familiar with the Irish setting is, so like I was looking at the 3 lessons at this year's math counts. There are 3 teams. All right, Dr. Brosnan told me how to pronounce this. Colaste? So I'm sorry, I cannot speak Gaelic. So I was, when I was spending time with the students before I came in, Dr. Brosnan suggested that maybe we can have students wear name tags to help me identify their names. I soon realized when they said their name and asked them how do you spell it, spelling just doesn't match the sound. So I think the name tags would have done almost nothing for me in this setting. Another thing that I was thinking about was I created a little seating chart and had the students just write down their name, the same thing. If I can't read their names, it doesn't help. Anyway, so first team has 4 teachers from this school. Second team has 3 teachers from RD Community School. I can read that. And then the third team actually has a cross-school team from 2 different schools. So I wasn't sure what's the typical size of the mathematics department in Irish secondary school is, or in the common practice of lesson study in Ireland right now, when you have a lesson study team, who that involves. Is it almost the entire department in the school, or only part of the department? Right? Is lesson study being practiced as school-wide activity or department-wide activity? Are other teachers at your schools who are in green dots, coming to observe as a part of the lesson study team? Or are they more like a blue dots, if they do ever come? Or do teachers from other schools participate, those blue dots? Right? And I ask this because in Japan, these are at least 3 kinds of lesson study being practiced in Japan. Probably the most common one is a school-based lesson study. Right? And usually all teachers from school, or maybe all teachers in the same department for the secondary school level, post-primary school level. And then they try to address the school lessons and then try to address like a school mission, school goals they have, and how best to achieve those goals within their subject areas. Whatever the goals, mission they have, what can mathematics teaching do to help achieve those goals? And the main purpose is achieving systematic and consistent instructional and learning improvement in the school as a whole. So it's not just this pocket of 2 or 3 teachers, but we want this to become sort of a systemic thing. They also practice this cross-school lesson study, or sometimes district-wide lesson study. Those are organized as inter-school lesson study groups, so it's almost like the third group that's presenting, that was the 2 cross-school members, is almost like that. Right? And they're usually subject-oriented, even at the primary school level, where in Japan the teachers teach every subject. They tend to have sort of a subject focus in these kind of settings. And the idea is that the communication among the schools in the district, exchanging ideas, and then improving instruction in the whole district. Then another aspect is this cross-district lesson studies, or sometimes regional or even national level. And in those lesson study, oftentimes they try to develop new ideas for teaching, and they propose the new ideas, and they sort of subject themselves to the critique by other colleagues, what they think of those new ideas. So the purposes of these practices are sort of different. School-based one is really trying to improve school-wide instruction. And district have a bigger, wider purposes, and the national is really more like a pushing the field forward kind of ideas. And this was also the case, and it still is the case in the US setting too, when we implement lesson study, that a lot of lesson study practiced in the US is not really school-based, but it's not really district-wide or cross-district either, because it's often done by the teachers from the same school. Right. So one of the challenges that I see in Irish lesson study practice as you move forward is this idea of broadening lesson study team, right? And making lesson study as a school-wide or district-wide professional development activities. How do we entice your colleagues who haven't been involved in lesson study to be involved in lesson study? And then situate the research lesson planning team within a broader lesson study team so that you have more opportunities to observe and discuss research lessons. One of the things that, especially in the US settings, I'm not quite sure how applicable it is in the Irish setting, is that we tend not to give enough credit to what teachers can learn from observing lessons. I think we can learn a lot about teaching and learning when you start observing others teaching mathematics. Akihiko Takahashi, he's a very good mathematics teacher. I'm amazed at his teaching. I'm not anywhere near as good as he is. But whatever a skill I have as a mathematics teacher, I think 95% of that came from observing many other Japanese teachers who are teaching mathematics in the Japanese schools when I spent 7 months in Japan back in 2000. I observed many, many lessons, and I've seen many amazing lessons. And I've seen many lessons, I cannot come anywhere near close to it. But I started picking out some bits and pieces about teaching mathematics from observing, and also based on my own study of mathematics education, about my own study of how students learn mathematics, and making sense of their practice and how consistent it is with the way I understand how students learn mathematics. So situating the research lesson planning team within the broader lesson study team allows that lesson study team members to have more opportunities to observe and participate in discussing the research lessons. And another challenge is making research lessons more public. I do not know whenever however many research lesson study teams are represented in here, but whenever you practice research lessons, how public that is to the teachers within your own school building, but the teachers from outside of your school buildings. A research lesson allows research lessons like these, when we write something and submit the public for possible publications, we get those peer review critiques by others. Research lesson has something like that too. You're presenting your research findings, and then you're subjecting yourself to the critique of your professional colleagues. But the other aspect of the research lesson is really it allows researchers or the teachers to build on other people's work by observing other people's what they have done in their research. And that is one of the criticisms that often given toward the educational researchers, that we don't build on each other's work. And we don't want to keep doing, I guess, this whole idea of reinventing wheels. We want to be reinventing better wheels based on what other people have done. And that making the research lesson public provides that opportunities to help us build on other people's work. Then the second idea that I want you to think about is that lesson study, when we think about lesson study, it's a primary mechanism for ongoing teacher professional development. And it's definitely, that's the way it is in Japan. Right? Especially at the elementary or what you call primary level. But it's probably the case more than half of the lower secondary level, grades 7 through 9. But so it's oftentimes lesson studies used as a primary mechanism to implement any new ideas that is presented in the national course of study, which is probably equivalent to your syllabuses. But another role that the lesson study plays is that lesson study is a part of this feedback mechanism for the curriculum materials revisions. Or, okay, so that's something else that I'm learning. British English, or I don't know what's the right adjective there should be. Proper English versus non-proper English that Americans speak. We say review. And the revise means really changing something. So, but it's oftentimes the lesson study contribute to this improvement of curriculum materials. Oftentimes, revising doesn't necessarily mean to improving, but its intention is to improve, right? So the lesson study informs the revisions of textbooks and the national course of study. So pictorially, it looks something like this. So whenever the Ministry of Education revised the course of study with new topics, new teaching methods, Japanese teachers who study use the lesson study to make sense of what those new ideas are and how to practice that in their own classrooms. At the same time, the curriculum developers would use these revisions, the course of study, to create their new textbook series or new curriculum materials that teachers can use to teach. The lesson study will result in ideas for implementing new topics and teaching methods, as well as ideas for modifying the content and pedagogy based on their lesson study. So they feedback those ideas to publishers who are trying to revise their textbooks and inform those people who will be writing the next round of course of study. In Japan, the course of study gets revised about every 10 years or so. I don't know how often syllabuses are revised in Ireland. Some of you may be thinking, please don't revise again, and just at least until I retire, kind of. Anyway, but in Japan, it happens on a regular basis. And I think that's part of the reasons that the lesson study became this part of the feedback mechanism, because it changes every 10 years. That is given. It's going to change. And if it's going to change, might as well inform that change. Right? So the question is, can this happen in Irish settings? It doesn't necessarily have to be syllabus. It could be improving the textbooks as well. Right? And potential benefits that want to make lesson study as a part of these feedback mechanism is that the syllabus or the curriculum you have as a result will be more grounded in the practice. Because lesson study is a practice-based research. And that's informing the new revised textbooks or curriculum materials or the syllabus. So there should be less gap between what's happening at it's more like a best practice, current best practice, and the new curriculum materials. And I think it professionalizes teachers. It puts the teachers really at the core, right? Because they are the ones who know what's happening in the classrooms, and they should be the ones that telling these people how the textbooks, how the syllabus should look. Professional knowledge, building the professional knowledge base and developing the network of like-minded teachers, those are another sort of potential benefits. And then really, again, affirming the centrality of teachers in educational processes. I think that's very important. I think I heard that the Ministry of Education, Irish Ministry of Education, was supporting this conference, and I think that's great. I think the support from ministry, support from local education agencies, those are very important as well. In fact, in Japan, Japanese Ministry of Education often grants some lesson study teams, small grants, and part of that grants allows those teams to go beyond what the current course of study is mandating, because the ministry who really oversees the revision of course of study wants to hear from the lesson study teams what they learned from their research. So there are many ways that the Ministry of Education in Ireland can be involved, and so that they really to put the teachers in the center of this whole process of schooling and education. So this was the question I ended my 2013 keynote talk. Lesson study, is it nice to have or is it must have? I'm not quite sure where it is now, but I want to end today's talk with this question. Has lesson study become must-haves in Ireland? And I want you to ponder with this question a bit and think about how we can go from here so that lesson study becomes really a must-haves with more and more Irish mathematics teachers. Thank you very much.
Okay, as usual, and just like the last time, Tad, could hear a pin drop in the room, okay? Just to say to you, there's a cup of tea, cup of coffee outside, and the poster presentation is all down to the right, or sorry, to the left of the tea and coffee. Don't forget to put that on you tomorrow morning, right? It's for your lunch and so on, okay? So don't forget to bring that. And tomorrow morning we're kicking off at what time? I don't know what. I just keep turning up and it all happens. What time are we in the morning? 9, is it? I think we're starting in here at 9. Yep. I'll be here from 8, so I'm going to be here anyway. But I think if you're here registered, is it 8:45, Aidan? 9? 8:45 registration. Tad and the students from RD will be in here at 9 o'clock with lesson number 3. Okay? So safe home, and said please do have a cup of tea or coffee with us. Thank you. And thank you.